So the question is, can these kinds of finite potentials still yield bound states? We can envision a case like this, where this is u naught and this is u naught. This is u equals 0, and we're at x equals 0 here, and x equals L right there. If this was an infinite potential, we would have expected psi to go to 0 in this region, and psi to go 0 here. But if this is a finite potential, we won't require this to go to 0 exactly. Instead, we'll ask only that it goes to 0. So in fact, what we expect is something like a solution that looks like this for a sinusoid, but then damping off to 0. That would be something like an n equals 1 solution. For n equals 2, we then expect damping as you go out beyond the barrier, but something with 2 nodes. For n equals 3, and I expect the damping to be faster for the ground state. Because the decay constant, if you'll remember, is always this. Now, energy is lower for the ground state than it is for the excited state. So if I label this by n and these by n, then these damping constants are larger for the ground state than it is for the excited states. I also notice that the curvature of this shape right here is a little bit different than it would be for the infinite potential well. This function would have to go to exactly 0 if it was an infinite potential well, but notice that it's still bounded out. So if the curvature is smaller, that means the wavelength is larger. So if this is important bullet number 1, important bullet number 2. Is that the bound state energies are going to be a little bit smaller than the case of the infinite well.